Example number 2, a volleyball player hits a volleyball such that it moves upwards with a velocity of 6 meters per second straight up. So our initial velocity VI equals 6 meters per second. We know right off the bat also that our volleyball starts at 2 meters above the floor. That means that's a position they're giving us. So our YI, that is our initial Y position, is at 2 meters above the floor. Now the question is, how long will it be before it hits the ground? So think of it like this. You've got this volleyball player. I'm going to write it over here on the side. And he or she is bumping the ball. And the ball starts 2 meters above the floor. And it goes up in the air, and it comes back down, and it lands on the floor. So if it starts at position 2, what's the final position? What's the YF? That would be 0, at 0 meters. So that's our YI here. Our YF is 0. So our final Y position is 0 meters. We also do know that our acceleration equals negative 9.81 meters per second squared. And we want to find our time. How long will it take for it to hit the ground? Well, these two values right here can be combined if we have YF minus YI. That gives us our delta Y, and some of our equations are in terms of delta Y, so let's just combine them right now. What is YF minus YI? That's 0 minus 2, so that's negative 2 meters. And if you think about it, if the ball starts here and winds up down here, it has displaced itself negative 2 meters. That distance right there. So what is our time? Well, we have the equation that probably works the best, and that really that only works for us, is this one. That is where we have our change in Y, or it used to be what we call change in X, but either way, it's our displacement. It's our vertical displacement equals initial velocity times time plus 1/2 times acceleration times time squared. Now I'm going to rearrange this because we're going to be solving for time. And we've got a t squared and we've got a t. So what do we do about that? How do we reconcile them? Well, we can rearrange this so that it looks like a quadratic formula. So let's rearrange it up here. So we're going to have 1/2 at squared plus initial velocity times t minus our delta y equals 0. That follows the format of, I'll write it up top here so it's not in the way. Ax squared plus bx plus c equals 0, and then you go about solving the quadratic formula that way. You plug in values for a, b, and c. Well, what are our values for a, b, and c down here? Well, it's whatever precedes the value that is squared and is by itself. What I mean by that is that here's our x value right here. And so this would be our a, this would be our b, and this would be our c. Well, what are these values? Well, it's 1/2 times acceleration. So that's 1/2 times negative 9.81 times t squared plus initial velocity times t, that's 6. I'm not going to put the units in right now. 6 times t minus, or I should really put, oh yeah, I'm sorry, minus negative 2 equals 0. Because we have this as a minus right here because that came from the other side. So our a value is going to be negative 4.9, right? Because negative 4.9 is 1/2 of negative 9.81. Our b value is merely going to be 6, and our c value is going to be 2. So if we put those in for our quadratic formula, whether you use the quad form program or whether you do it out longhand or if you use a program on the computer, it doesn't really matter. These are our values for our quadratic formula. And we're going to come out with two answers, as we always do when using the quadratic formula. One's going to be positive and one's going to be negative. The negative one we can just throw away right off the bat because time always has to be positive. So our time is going to be equal to 1.5 seconds. Now, what's the ball's maximum height above the floor? Let's write down our knowns again. We've got our initial velocity of 6 meters per second. We've got a final velocity. Now it's not coming back down to the floor, it's going up to the maximum height. So here's where we can use our VF of 0 meters per second. Our initial position equals 2 meters. We don't know what the final position is. YF is what we don't know, but we do know our acceleration as well. Our acceleration is negative 9.81 meters per second squared. So we have our initial velocity, our final velocity. We have our part of our displacement, and we have our acceleration as well. So the equation that works best for this is going to be our final velocity squared equals initial velocity squared plus 2 times a times, actually I should call that times g. Well, I'll just write out the original equation, 2a delta x. That's the original equation that we learned. The one that we revised slightly for this chapter is VF squared equals VI squared minus 2g times delta y, but they're, again, virtually the same thing. And if you think about it, I'm going to erase this delta y here. How can we rewrite that? Well, our delta y is simply our final y component minus our initial y component. Okay, so this is what we really want to find. What's the actual height, the maximum height above the floor? Well, let's rearrange this so it can actually be solved for y sub f, our final y. I'm going to subtract vi squared from both sides. So vf squared minus vi squared. And I'm going to divide by negative 2g. So this will come down into the denominator over here. And then we're left with our yi all by itself. We're going to add that to both sides. Plus our initial y tells us our final y position. Well, all this other stuff we know, and so we're going to solve for that. So what is that? What's our final velocity squared? Well, that's easy. That's 0. We're going to subtract our initial velocity squared, 6. So it's that value. You know what? I should put that inside the parentheses because we're going to square 6 and then subtract it from 0. And subtract, or divide it by negative 2 times 9.8. Or you know what? Even more appropriately, we can do 2 times negative 9.81, reminding us that the negative really comes from the 9.81 meters per second squared. All that plus our initial position, that's y, so that's 2 meters. Alright, so 0 minus 6 squared over 2 times negative 9.81 plus 2 meters gives us our yf. And what is our final y position? That should be 3.8 meters. 3.8 meters above the floor. That's it for example number 2. Check back for the next video for examples 3 and 4.